Hello, Facebook students. Today we are going to review the essence of calculus. Differentiation, referring to a derivative. We have our graph today with the green curve called a parabola. And in red on the grid, we have a line, it's linear, and it is showing the slope of the line. And in my previous sessions, I reviewed how to calculate the slope of a line, and I will give the formula. So we're just going to show how algebra progresses to the essence of calculus. Let's begin. If this is helpful to you and other students that are taking calculus, please like and share. Hope that you are healthy and safe, and let's get ready to problem solve. Okay. So, as I stated before, this green function or curve is called a parabola. And the equation for this parabola is y equals x squared, or x raised to the second power. And we have our x-axis and the y. So y is vertical and x is horizontal. Okay? And this is when you have a diagonal on a line, this is called your slope. Slope is equal to m, and this line is tangent to the parabola, meaning that this slope, this parabola is hitting at this point, okay? So I'm going to go through the vocabulary of this graph, and I want to point out the components that are comprised in the essence of calculus. Okay, so let's go to our slope, and this is linear. Remember, I'm big on vocabulary. Linear, and the root word in linear, and I think I went over this in one of my sessions, is line. So we have a line, okay? And the formula for, well, how do we solve for the slope? In order to solve for the slope, let's write it over here. M is our slope. And we have y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay? So, also, this is also, you can say, the change, we use a delta symbol. The delta symbol it comes from the Greek symbols, or the Greek alphabet, or I hope I'm saying it right, but it is a Greek symbol called delta. Okay, so all those deltas that are out there, we use this in our math. So we have the change in y divided by the change in x. This symbol is a Greek symbol. So this delta, it's called delta. It's a Greek symbol, and it represents the change in y, okay? Change in y, and we divide that by the change in x. So that's where this slope, well, that's where this derivative or differentiation that we're going to use comes from the slope, the tangent to the curve, to the function, to the parabola. Okay? So I wanted to make sure vocabulary, see how it's very, very important that you know your vocabulary, because it's really, your formulas are derived from your definition, from your vocabulary. So once you know that, you can solve a problem. All right, so that's how we have the change. Change means difference. So that means you're using a minus symbol. So the minus symbol represents less or the difference between two numbers, okay? Or if you're dealing in the real world, if you want to look at the changes of the rate or the numbers that's changing in COVID-19, okay? There are people that are using software that have the formulas that's behind the scenes that's crunching all of this data, okay? So this is how you use things in the real world. All right, so let's get back to this. So I want to go through what this represents. So because of the slope, we have a tangent to the curve, to this green parabola curve where they meet at a point, okay? All right, and the point lies on this line, okay? So this line could be y equals, I'm not sure, I just create this, but this line could equal like y equals 2x plus 2. I'm not sure, I just made that up. But that means that your slope is 2 and here's your y-intercept. But we're not crossing, we don't know what it should cross the y-axis at 0, 2, but we're not there. So I'm going to erase this, but that is the equation for a line. Okay, and I'm just going to put it in the formula. So the equation of a line is equal y equals mx plus b. All right, so we'll just say that for right now because I really don't know what those values are. But this is for the equation of a line. All right, let me just put that there. So you will have it in your notes, equation of a line. See how all of your algebra builds up to get you to calculus. All right, so let's move on. Want to make sure I cover everything. So the essence of calculus means that you were doing differentiation, which in calculus we call it a derivative. So the essence of calculus is a derivative. Okay, so I'm going to, so let me get deeper into this. So while I have it here, so we have the change in y divided by the change in x. And this x, right, the change in x, what it does, it decreases, causing the line, causing our equation, causing this line here, causing the line, to approach, this is very key, approach the tangent. Remember, I mentioned the tangent previously. So this is very important. So the change in x decreases, causing the line to approach the tangent. And where did I say tangent? Here's our tangent. And tangent means we're right here at the point where the curve, the parabola, this point meets at the exact point on the line between the equation of a line and the parabola. Okay, so that's very, very important. All right. So I'm going to give you now that we have this, and I'm going to erase it, so this will build up to something. All right. But we always have to refer back to our graph. Okay, so I'm going to erase it. If you are not on with me live, you can always replay, get your paper and pencil out, and jot this down, take notes, review it, and hopefully it will be very beneficial to you. All right, I see we have a little avalanche here, so give me a moment. I guess I've been using this board that I'm wearing it out here. Thank you for your patience. Gotta fix my board here, my easel. But as you, hopefully you're writing those notes down. That gives you time to, think about what I said about differentiation. The change in y divided by the change in x. Okay? You probably didn't know that was part of calculus. Okay. All right. Hopefully that doesn't happen again. I've had this easel for quite some time, and let's see, are we back? Oh, okay. Not sure if anyone is there. If you are there, please wave at me. Okay, moving right along. Okay, so now we're going to, now we're going to get right into calculus. So we're going from y equals x squared. Okay, that is the parabola. So when you see something like this, this is called a parabola. It can go pointing upward. It can also go pointing downward or sideways. Doesn't matter how that parabola is drawn. But when you see a curve like this, it is called a parabola. All right? Now we're going from this to differentiation. Or taking the derivative of the parabola, of a function, of a curve, okay? Differentiation. Make sure I spell this right, differentiation. Okay? So, when we write a differentiation or a derivative, well, we're going to write the differentiation, then we're going to take the derivative of this function. So that is written as dy, the change in y divided by the change in x. Okay? So we have to say equal, and what we're doing is, since we're doing the change of y divided by the change in x, then we have to write what that function is. So it's x raised to the second power, x squared. And remember, y and x are our variables. And we don't know what that number is. We don't know what x represents. But we can take the derivative of x squared. All right? So, let me just give you the definition quickly. The definition of differentiation or derivative is, it is the equivalent. The equivalent, and this is very important. I know it's a lot of writing and words, but you know you have to read before you learn how to count. So reading is part of math. Everything goes together. So it's the equivalent to finding the slope. Remember, it's the equivalent to finding the slope. I'm going to use m to represent my slope. To finding the slope, to finding m of the slope of a tangent, of a tangent. That word tangent is going to keep coming back. Of a tangent line to the parabola, wow, these are tongue-twisting words, parabola, at a point. Very important definition. So I wrote it out so you can have it in your notes. The equivalent to finding the slope, here's our slope m, of a tangent line to the parabola at a point. Okay, so that's what differentiation represents. All right, so let's erase this. Make sure my board doesn't fall apart this time. Hope everybody can see this clearly. Let me check. Okay, hi Malcolm. Thank you for watching. If it's very helpful to you or you believe it could be helpful to other students, please like and share. Okay, so let's move on. Just want to make sure I covered everything. All right. So as I said, the slope of the line equals, well, let me go back. I gave you the definition. Now let me just add to this. The slope, here's our slope. It's the diagonal where we meet at this point. The slope of the line equals the derivative of the parabola at the point. So I'm going to keep this one here because this is what we're doing today. The slope, which is my m, okay, the slope of the line, equals, well, let me write that out. I don't want to abbreviate that. Equals the derivative. Here's that word, derivative. That's what we're doing. We're going to take the derivative of this function. A function is written like f of x, okay? F of x is the same as saying y equals x squared. That's the same as this. So we can take the function of it, okay? So let me just write this. Don't want to miss that because I mentioned function. Function, what's your junction? Or remember back in the day, Schoolhouse Rock? Conjunction, junction, what's your function? Well, we are using functions with the essence of calculus. All right? So let me go back to this. The slope of the line equals the derivative of the parabola, that's in green, okay, at a point. Just want to make sure what I wrote in my notes is clear. All right? So now that we have all of the definitions out of the way, now we can go right to how do we take the derivative of y equals x squared. So here we go. The first thing we're going to write is dy divided by dx equals x squared. So the definition says, in order to do this, we are going to reduce this exponent, this power, by only 1. How do we do that? Okay, so the first thing we do is we're going to have to take, well, let me go back. We have to now take the power, so we're going to take 2, we're going to multiply to x, and we're going to say 2 minus 1, and what is 2 minus 1? It's equal to 1. So let's rewrite it to make it look like it's a derivative. All right, so we have 2 from the power here in front, now becomes our constant. Multiply, I can put a little dot here, multiply to x, and then we subtract the power that we have here by 1. So we have 2x to the first power, and in a textbook they would not leave that 1 there, that power 1, because it's understood when you have a variable without a power or exponent that it is always 1. So let's rewrite it. Hope you can see this. So the derivative is 2x. Okay? So we took the exponent or power, multiply it to x, subtract the exponent by 1, it reduces by 1 every time. And we come all the way down to our final dy divided by dx, or we can say change in x, change in y over the change in x. Okay? That's the slope, okay? So that's basically what, just erase that. That's how we go from our function to our, this is called the derivative, or we differentiate. Tongue twisters, differentiate, okay? So that's what we did. So let's just practice a few examples to see if you have this. I'm going to change up the power, and we're just going to look and see if you understand it. This is just like a table of our functions, all right? So if this is very helpful to you and you believe it would be helpful to any other students that's taking calculus, or they're rising seniors, or they may be rising juniors that may be advanced and they're getting ready to take calculus, This is the beginning of calculus. It is the essence of calculus with differentiation, sorry. Okay? So I'm going to erase this. If you missed this, please replay. All right, so let's go to some examples, and I'm going to create a table so we can see how to do this. So here's my table. Oh, let's go this way. We're doing y, and we're going to have dy divided by dx. All right, so we're going to differentiate. So let's do, what if I have x cubed? How would I differentiate this? I would say 3 multiplied to x, and I would subtract 1 from 3, which is 2. So this function, which remember I said that this could be called, for f of x is the same as saying y. That represents function, okay? It's not a linear, it's not a line, it's not an equation of a line. It's a function. All right, so I differentiate by saying 3 now becomes my constant. It comes in front of the x, which you're multiplying it to the x, and you're subtracting 1 from 3, which you get 3x2. All right, what if we had x to the 5th power? That would be 5x. I subtract 1 from 5, and that would be 4. So the derivative is 5x to the 4th power, or 5x to the 4th. All right? So now I can give you the definition of how you take the derivative of a function. And to do that, you're saying n, let me write it, let me just make it flow here so we can have it in the table. So if we have x to the n power, we don't know what that n power is, that would be n times x, n minus 1. So that's how we were able to take the derivative of this function and this function. So this is 1, 2, and this right here is how we differentiate. Okay? So I know that this may seem like it looked difficult, but really, it's really easy. So basically, if we go back to our graph, we come over, we have our y value, here's the function here, and when we come over at this point, we're coming down to an x value. Coming down to our x value. So that means, remember I gave the definition that the change in x, it decreases, causing the line to approach. So it's causing, as we get closer, like if I take the chord and try to hit the point of this curve and hit right at that point, what we're doing, that's called a secant line, or I'm sorry, this is like a secant tangent. I'm a secant line, but when we're taking this right here, we're trying to get closer and closer until we hit that very point on the line. All right? So it's like as you go over in x, you come over and you meet somewhere at y. So whatever x is, you're going to square it and it becomes y. So just say if that x was 2, if we put that in this equation, just say we put it in this equation, 2 raised to the 2nd power, that means it's 2 times 2. See, we're back at multiplication and doing our multiplication. We're back at using algebra or basic arithmetic. So 2 squared, if this is 2, then this y would be 4, because 2 times 2 is 4. And that proves it on the graph. Go over 2, you put it in the function on the table, that becomes 4. Just say we put 2 here. 3 times 2 raised to the 2nd power, that is 3 times 4, which is 12. So if we put in 2, take the derivative of it, it would equal 12. So if we were to graph that, then if it's 2 here, according to this equation, then it would go up 12. So that would be a steeper parabola. The parabola will be skinnier. It will kind of probably go up like this instead of wider, like come out like that. Okay? So that's how you apply it if you were to use values. Okay, so I'm going to erase this. But this is the essence of calculus with problem solved. All right, I hope that this was helpful to you today. Hope you learned something. Please don't forget to like and share. All right? So, thank you for watching. Stay safe and healthy. Peace out and have a great day. Don't forget to like and share. Hi, Kevin. Hi, Steve and Joyce. Okay. Don't forget to like and share. Share the love of the essence of calculus. All right. Hopefully, I'll be coming to you tomorrow with something just basic. Either tomorrow or Monday. I'm thinking about what I want to review. So hopefully it won't be calculus this time. Maybe it'd be something that my pre-K students or kindergarten or, my primary students can feed from. All right. Thank you for watching and have a great day. Again, peace out with problem solved.